Hi everyone, welcome to this class where we are going to be looking at reflection by spherical mirrors. So I'm sure you have seen reflection by plane mirror where you guys, when you comb your hair in the mirror, so that is a plane or a flat mirror. But here we are going to be more focused on reflection of spherical mirrors, which means curved mirrors. And you guys know what are the two important spherical mirrors or the two curved mirrors? Concave and convex mirror. So make sure you guys watch those videos. We have very interesting videos on that, and I'm going to go through the important details in this class, and in another class we are also going to be doing the ray diagrams in the next class. So all the details of how to draw the diagrams I'll also talk about in the next class. So make sure you guys watch the previous video, and definitely this class is going to be a very important revision of this topic. So let's get started. Now, before I begin, I just want to say, do check out the other courses on our website. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other courses, do take them and please do share it with your friends. For ICSE students also, we have physics, chemistry, biology and maths for classes 8, 9 and 10. Once again, do share out our courses with your friends. And if you want to learn coding, we have Java coding, we have Python programming. So we have these excellent coding courses for you. And we also have physics and chemistry for the Cambridge IGCSE, which is the international board. So make sure you have shared our courses with your friends, and also you have subscribed to our YouTube channel. We also have our Facebook and Instagram page. It's called Manoj Academy. We keep posting interesting content there as well. So make sure to follow us there. All right, with that, let's get started. So let's start off with a very simple puzzle. What goes through water without getting wet? So what is your answer going to be here? What do you guys think? What goes through water without getting wet? So we can see the correct answer here is going to be light, even sound. Absolutely right. What can go through water? Light, sound, without getting wet. Why? Because these are not matter, these are forms of energy. So they can pass through water, but they don't get wet. And of course, we are going to be dealing with a lot of light today with reflection of light topic. Very good. Inyan Ramraj is also saying radiation. Excellent. Yes, because light is an electromagnetic wave. It's like a form of radiation. So when we talk about light, let's understand this concept of ray and beam of light very clearly. Okay, like you can see the light is switched on in your room, or if you take a lamp or a torch. So a simple example is, if you take a torch like this, have you guys seen this? You can see this kind of beam, what we call, like this kind of layer of light. Okay, so that is called a beam of light. Or when you see the vehicles, the bikes and the cars, you can see their beams, especially against in the pollution or the dust, the beam is more clearly visible. So this is what we call as that spread of light, right? This column of light that comes through is called the beam of light. Now when we talk about the beam, we can imagine that the beam is made up of many thin lines of light, or what we call as a ray of light. Now how do you understand a ray? If you imagine you take this torch and you cover it with a black paper. So you cover the torch with a black paper, and there is a tiny hole over here. There's a small tiny hole here. So then you can imagine this kind of line of light is coming out through this tiny hole. Okay, and this is what we call as the ray of light. What is the thickness of this ray? Or if I ask you in mathematics, what is the thickness of a line? Does a line have a thickness? No, it's absolutely right. It has a length but no thickness. Same way, ray has no thickness. So it is sort of an imaginary concept, right? You can't really see one single ray. So even if some of you might be thinking, okay, what if I talk about a laser pointer? Does a laser pointer throw a ray of light or a beam of light? If you take a laser pointer, will it throw a ray of light or beam of light? Again, it is very thin, but even that thin thing is a beam of light. Very good. It's a beam of light. Absolutely right. Made of many thin rays. Okay. So it is almost, technically impossible to get a single ray, but by drawing this line, it makes the concept easy, considering light as a ray. And we know light travels in a straight line when it's going in one medium. So rectilinear propagation of light means we are talking about a straight ray, thin line of light. And beam is a collection of many rays. So you can see that beam is made up of many rays. It's a collection of all these rays. So please keep this important concept in mind. Rays like this line of light, and we always make it travel in a straight line, and this is a collection. Beam is a collection of the rays. How do we know we are dealing with a ray or a beam? Normally when you have a light source, you will automatically have a beam, but we consider some parts of it, or we consider a line of it, so a ray. So as we'll see in the ray diagrams, we consider the the extreme ends. So if you talk about this beam, if I consider this top ray and the bottom ray, right? So I can understand there's light in the middle. So there, to make it easy, we have considered only 2 rays. You can consider 3, 4 rays. Actually, a beam has how many rays? Can you guys tell me? A beam is made up of how many rays? 1, 2, 3, 4, how many? What do you guys think? Basushri has the correct answer. Ishan has the right answer. Rohit, Aditi Shukla, Ghost Rider, please change your name to your real name. Shaurya Gupta, Vijay Lakshmi, yes, uncountable. Absolutely right. The correct answer is infinite or uncountable. A beam is made up of many lines or rays of light. Okay, so beam is infinite or infinite rays. Beam can be divided into 3 types of beams. You could have rays like this, where what do you see over here? Here you can see that all these rays are parallel to each other. So this is what is known as a parallel beam, where the rays of light are parallel to each other. Now you could have that maybe the rays of light are coming out of this point. They are emerging from this point and spreading away. So what do you call this type of beam? Where the rays of light are spreading away. So when we say spread, we use the word diverges. Okay, very good. So this is known as a divergent beam. And when the rays are meeting at a point, so if you have rays of light going and meeting at a point here, then what do you call this kind of beam? So again, it's a beam because a beam is a collection of one or more than one rays, right? Actually infinite rays, but we consider, for simplicity, we consider a few. So if we consider, again, beam is a collection of rays. So here what we can see, that they are meeting at one point. So this is called a convergent beam, because we can say, or converging beam, right? We can say it converges to a point. So diverging means spreading away, converging is the opposite, rays of light meeting at a single point. So now let's talk about reflection of light, because we're going to look at reflection topic. What is the meaning of reflection of light? So all of you know a mirror, and what is the definition? Reflection is the bouncing back of light rays after hitting a surface. Just like if you take a ball and you hit it on the wall, it bounces back. Same thing is happening here. When light rays are hitting a mirror surface, so when light rays are coming like this, they're hitting a mirror surface, they're bouncing back from it, right? So they're hitting and bouncing off it. So if you draw it over here, when light rays hit a mirror surface, so what will happen? These light rays will bounce off, right? So they'll bounce back. So they'll not go through, because a mirror is opaque, it is not transparent. So light is not going to simply go through the mirror, it is going to bounce back from the mirror. So it's going to go like this. So this is the meaning of reflection of light. And mirror, we always draw it like this. We draw a straight line, and these dashed lines means this is the back of the mirror. This flat plain side is the reflecting surface of the mirror. So remember the laws of reflection. You have studied this in the lower classes as well. That what are the laws of reflection? The incident ray, there are 2 laws, right? First law and second law. The first law says the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. First law is the little difficult one. Let's understand it. Okay. So what is happening here? The ray that is falling on the mirror. So here I've taken a simple single ray, right? Not a beam. I've just taken one ray here. When it is falling on the mirror, this is called the incident ray, because it is one which is incident on the mirror. So this is my incident ray. And you know what happens? When it hits the mirror, it's going to bounce off it, right? So this will happen something like this here. And we always draw these arrows. Please remember, drawing the arrow is very important. In fact, my physics teacher used to give us 0 if we had a ray diagram without arrows, because like you know in mathematics, ray has a direction. So here we are showing the direction of the light. Here you can see the light is going downwards. After reflection, it bounces off. So make sure you guys draw those arrows, not just simple lines, right? Ray, we draw it always with the arrow. So this is the incident ray. After reflection, what is this ray called? Obviously, this will be called the reflected ray. And the normal, what is the normal here? Normal means it's not a ray, but it's an imaginary line that is drawn perpendicular to the mirror. Normal is an imaginary line drawn perpendicular to the mirror. So let's draw it. So normal will look something like this. An imaginary line drawn at the point of incidence and perpendicular to the mirror. So something like this. This is our point of incidence where the incident ray hits. So all of you can see, and we can label this normal as n dash, and let's call this the normal. I have shown it with the dotted line because it is an imaginary line. Now what is our first law saying? The incident ray, the reflected ray and the normal all lie on the same plane. This is the thing that confuses most students. Where is this same plane here? First of all, what does a plane mean? Here we are not talking about the aeroplane, right? What is a plane? Plane in mathematics or physics means a flat surface, right? So just like if you see your table surface or your laptop or tablet, that plane is the flat surface or the floor here, right? Plane. So can you guys tell me where is this flat surface that the first law is talking about? The incident ray, the reflected ray and the normal at the point of incidence. So point of incidence is this O here. So point of incidence O, okay. So where do they lie on the same plane? Is the same plane the mirror? Do you guys think the plane is the mirror here? Yes or no? What do you guys think? If I label the mirror as mm dash, is that my plane? See, the first law doesn't even talk about the mirror. Otherwise they would have said mirror, right? So look at the law. It says the incident ray, the reflected ray and the normal at the point of incidence all lie on the same mirror. They would have written. No, they said same plane. So plane is not the mirror here. Then where is the plane? So the question is, where are they lying on? So just like when you are sleeping, you lie on a bed, right? So bed is your plane, it's your flat surface, you lie on the bed and sleep. Here, where is the incident ray, the normal ray and the reflected ray lying? Where are they lying? Where is their bed? You can see this flat surface. Very good. Basically the digital board here, right? Or if you draw this diagram on your paper, it is your paper, your copy, right? That paper, that is the flat surface. So basically when we are talking about the plane, it is this whole area. This is our plane. This thing, right? Because can you see the incident ray, the normal and reflected ray are all lying on this flat digital board. What does it mean that they are not, they are in the same plane? Is it that incident ray is like this and reflected ray is coming out in 3D, coming out of the digital board? No, it is lying on the same flat surface. Normal also is drawn on the same flat surface. It is not outside, correct? So this is very important concept, that this is the plane here. Okay, so first law is done. Let's look at the second law, which is thankfully much simpler than the first law. I could never remember that whole sentence, incident ray, reflected ray and the normal at the point of incidence all lie on the same plane. Too many words there. But now I hope you have understood it. Now let's look at the second one. Angle of incidence equal to angle of reflection. Okay. One very important thing is, normally when we measure angles in geometry, we measure like this, right? But not in physics. Angles are measured with the normal. Okay. So when we are talking about the angle of incidence here, the angle of incidence is going to be this angle. The angle between the incident ray and the normal. And I'm going to mark it as I. So this is my angle of incidence I. And then the reflected ray and the normal. So this is going to be my angle of reflection R. So the second law is basically telling us angle I is always going to be equal to angle R. Never slightly less or more, always equal. Which means if you measure this with the protractor, so let's say you take a protractor here. Do we have a protractor here? There you go. So if you take a protractor and you measure this angle, so how will you have to measure it? You'll have to place it against with the normal. Then when you measure this angle, okay, so this measure is going to be exactly equal to this measure here. See, let's say it's 46 or 50 approximately, right? So if this is 50 degrees, this is also going to be 50 degrees. Clear? So you always have to measure the angles with the normal. This other angle is actually called the glance angle. Okay, the angle made with the mirror. But remember, angles are always measured with the normal. So if this is 50 degree, this is 50 degree. If this is 40, this is 40. If this is 30, this is going to be 30. Angle of incidence is always equal to the angle of reflection here. What is the angle of incidence and reflection in this case? So suppose we have a ray of light which is falling directly on the mirror. So what do I mean by directly? That means perpendicular. So let's say this is 90 degree. Can you guys work out and tell me what will be the angle of incidence and angle of reflection here in this case? So let me remind you again, angle of incidence, angle of reflection is always measured with the normal. So whenever you're talking of angles, first thing you do, don't be lazy, draw the normal. So everybody draw the normal here and the answer will stare back at you. So what is the normal? Normal is going to be again imaginary line drawn perpendicular to the mirror. So will you guys agree? Is this not our normal? N dash. So normal is, the incident ray is actually along the normal. So what is the angle between the incident ray and the normal? And reflected ray will again be, once it hits like this, you know the reflected ray is going to go back like that. Okay. So what is the angle between the incident ray and the normal? We can clearly see angle I is going to be 0 degrees. And by second law of reflection, angle R is also going to be 0. We know if it hits like this, it's going to go back. So the angle between the incident ray and reflected ray is 0. Angle between the incident ray and the normal is 0. And we always measure with the normal, not with the mirror. Glance angle is 90 degrees. This angle is actually called angle of glance or glance angle. Okay, that is 90 minus the incident angle or 90 minus the angle of reflection for the reflection gaze. So here it's going to be both 0 degrees. So now we have done the basics of, what is beam of light, ray of light and all the reflection basics. Now let's look at spherical mirrors and we are going to take a practical example of a spoon. So I would encourage you that after this class, when you guys are having dinner, maybe I'll also do is I'm going to pick up the spoon and please take a look that when you look at this side of the spoon, the front side and the back side, look at how you look in the spoon. It's actually quite funny, right? So you'll see in some cases you're looking inverted and you can try moving the spoon. So you take the spoon, move it forward, backward and see how you look there. Similarly here, you try inverting the spoon and seeing how you look at behind it, and you can see that the spoon, and take a nice big shiny spoon, right? And spoon is a reflecting surface. Okay, and these are basically curved mirrors. So previously in all the discussion we did, these were all plane mirrors, flat. These are all plane mirrors. Now we are going to the interesting topic of curved mirrors, also known as spherical mirrors. What is the meaning of a sphere? Spherical means sphere, sphere means like a ball. Okay, so what is happening here? But where is the ball here? This is a spoon. Actually the spoon is like part of a sphere. So if you think about it, why is it called a spherical mirror? Because it is part of a larger sphere. So as if this curved surface has been cut off from a sphere. Similarly here, if you take this, as if this curved surface has been cut off from a sphere. Can you guys see that? So that is what we call as a spherical mirror. Now there are two types of spherical mirrors here. That is why spoon is a very interesting example. If you look at this part, right? So when the spoon is curved, like you're going into this cave, right? What is this type of mirror called? When you're looking at the front part of the spoon with which you pick up your food, not the back part. What is this type of mirror known as? What do you guys think? Very good, very good. And the very simple way I remember it is, it's like this hollow curved part where you can enter it, right? As if you're going inside a cave, right? So you're going inside this cave. So this is called the concave mirror. So this reflecting part is called the concave mirror. And if you flip the spoon and you see yourself at the back of the spoon, you can see this is bulging outwards, right? Now you can't enter the cave because it bulges outwards. So it is bulging like this. This is called the convex mirror. So spherical mirrors are categorized into two types, concave and convex. Remember, spherical mirrors are the curved mirrors. They are part of a larger sphere. They are not flat. They have to be curved. So we use our mirrors in our daily lives, right? All the time. So there you can see, and you guys have probably seen this video. If you're not, please watch the other videos also given in the course here. So can you identify what are the different types of mirrors here? So when we comb our hair, this mirror that we're using, what is this type of mirror? First one is definitely a plane mirror. Excellent. How about this one? This is famously known as a shaving mirror. Of course, you can use a plane mirror for a shaving mirror, but normally this one, which is a shaving mirror or a makeup mirror, the advantages, so there you can see I'm, trying to shave here. So the advantage is you see a magnified version of yourself. Okay. You look larger in the mirror. So that makes it very easy to shave because, you can shave carefully and see yourself clearly. And it is also used for makeup or definitely by, makeup artists because it is, they see a larger version of the face, right? So this is called a makeup mirror. And what type of mirror is this? Very good. The answer is this is a concave mirror. Concave mirror gives a magnified version. So this answer is going to be concave mirror. And this last one that you see, you have seen this at street intersections or in parking lots. You have seen this kind of mirror. The advantage is it gives a greater field of view because it is curved, bulging outwards. So it gives a greater field of view. You are able to see more, and it is curved outwards. This is a convex mirror. So there you can see all these types of mirrors: plane mirror, flat mirror, and these two types of spherical mirror, concave and convex. They are being used all the time in our daily lives, in practical things. And so I would highly encourage you to look around. Whenever you see these types of mirrors, sometimes it may not be obvious because, the curvature is very less. It's slightly curved. For example, in the cars or vehicles, the rear view mirror is only slightly curved. It looks like a plane mirror, but it is actually convex for greater field of view. So I would highly encourage you to look around and, and you can see that in my videos as well. But try to spot what different types of mirrors are being used in your daily lives. Because the more you connect things, the better you'll remember things. So why use these different types of mirrors? The reason is the action is different. What do I mean by that? If you take a parallel beam of light and throw it on a plane mirror, what happens to it? So here you can see there's a parallel beam of light falling on a plane mirror. So after reflection, this beam just reflects off like this. So you can see the parallel beam remains parallel, right? So this becomes, it remains parallel even after reflection for a plane mirror. Now if you take a concave mirror, so again remember, this one is a plane mirror, this is a concave mirror, and here you have a convex mirror. So what happens here, if you throw a parallel beam of light on a concave mirror, what's going to happen? These rays will finally meet at a point. So you can see that they will converge to this point. So what this spherical mirror or the concave mirror does is it takes the parallel beam of light and converges it to a single point. What is this point known as? You guys might know about it. Just like the parents say, tell us, right? Focus on your studies, focus on your studies. So here, this is the focus, exactly. Because all the light rays are focused, falling on one point, So this is the focus, and this is basically, you can see that concave mirror has a converging action. It is a converging mirror. Because remember, we talked about light rays, when they meet at a point, we say they converge. So you can see the parallel beam of light after reflection, they are meeting at a single point, which is called the focus. So this mirror is having a converging action. It's a converging mirror. And what about this one? The parallel beam of light when they fall in a convex mirror. So how do you draw this concave and convex? How do you know the difference? When you draw this curved thing, this dash 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 is basically the back of the mirror. So this is the reflecting part. Same way here, when it is turned like this dashed portion is the back of the mirror. This is the smooth reflecting part. So when parallel rays are falling here, what happens to them? These rays actually end up moving further away. So after reflection, this is what happens to them. When they hit the mirror, they move back further away, they spread out, and if you trace them back, you can see that they will meet at a point which is also called as a focus. It's a virtual focus because it's behind the mirror. So this is what a concave mirror. Can you see the difference? Here it is converging the beam. Here when the rays of light hit, the beam spreads further. So this is in fact a diverging mirror. So this is a very important slide because it summarizes the difference of action of the three mirrors. We are throwing the same thing, parallel beam of light. This one, after reflection, the parallel beam remains parallel. Here, after reflection in a concave mirror, it converges it to a single point. So it is a converging mirror. This one diverges it away. And if you trace it back, it meets at a point behind the mirror. So convex mirror is diverging. Please remember this because sometimes there's confusion. You know, we mix up these two, or we think this one is converging, this is diverging. So please draw these ray diagrams, and yes, keep your pen and paper ready and make sure you are, when you're drawing it, see I've drawn all the arrows as well for the rays. Very important to do that. Great question by Madhav, that why did I use dotted lines here? Because these rays are real light, right? So these are real rays of light. But when these rays are hitting, this is the real light, this is just imaginary lines. Because they appear to meet, the ray cannot go through the mirror. Why? The mirror is not transparent, it is opaque. So these are basically your, they appear to be coming from this point. Does that make sense? Okay. So one very important thing, because this will come very useful in the next class when we do ray diagrams, how to draw these concave mirror diagrams and convex mirror diagrams. Of course, you can, just draw, you can draw it roughly by just taking a pencil and, just doing an arc like this. But even better thing would be to use a compass. So when you're drawing this mirror, better you use a compass and put, your compass point, let's say over here. So put your compass point here and then draw this curvature using your compass instrument. Okay. So when you put it like this and draw this curved thing, do you guys know what is this point known as? This is called the center of curvature, because it is the center of this big circle or sphere, right? If you think in 3D, it's a sphere. It's the center of this big circle. So that is why it is called center of curvature. So you put the compass at the center and draw this curved arc, right? So don't make it too much curved. It should have a certain, that will come by practice, So have this kind of curvature. This is your center of curvature. And then basically this will be your focus. The focus is exactly at the midpoint of this line and this center of curvature. So what is this line known as? So this is your concave mirror. This line that we draw through the center of curvature, passing to the center of mirror. Very good. This is called the principal axis. And where this thing meets is called the pole of the mirror, right? So that center of the mirror is called the pole. Focus is exactly between the pole and center of curvature. Now, a smart way to draw this is that since you know that this is exactly the midpoint. So for example, if this is, this is 3 centimeters between P and F, C and F is also going to be 3 centimeters, correct? Because focus is exactly at the midpoint of the pole and center of curvature. Focus is that point where the rays will converge for a concave mirror. So what is a smart way to draw this is that you first decide your this is called focal length, or you first decide this distances between these two. You can take any convenient thing, 2 centimeters, 2 centimeters, or 3 centimeters, 3 centimeters. So what you do is, using your ruler, so take your ruler like this and measure these distances, okay? So measure this distance, let's say it's 3 centimeters on your ruler. So this 0 to 3, this is 3 to 6. So mark these points first. Then you take your compass and then you draw the arc. So that way you're guaranteed that your focus is exactly in the middle. Okay, so this is very, very important. If your focus is not exactly in the middle, your ray diagram will go completely haywire, it will go completely wrong. So this is a very important trick, that rather than starting with the arc, you first measure these distances. Make it convenient. Good question, how big should you do it? Should you make it 40 centimeters? No, it won't fit your page. You can do any convenient thing, 2 centimeters, 2 centimeters, or 3 and 3, or 4 and 4, whatever is convenient for you. But make sure this focus is exactly in the center of P and C. This is called the pole, center of curvature. This is your focus. Okay. So this is how you draw your concave mirror diagram. If you do it like this, you won't go wrong. And then you put your compass point here and then use your compass to draw this arc. And make sure you draw these dashed lines, because this represents the back, the non-reflecting side. This smooth side without any dashes is the polished reflecting side of the mirror. And this line which joins P and C and passes through F, of course, is called the principal axis. How big should your arc be? You should draw it a little big so that, you can, as we'll see in the next class, the ray diagrams, the rays will not go outside the mirror, because you don't want the ray going outside the mirror. You can obviously extend it. Yeah, if you find 2.5 centimeters the best, you can use it, 2, 3, 2.5, but make sure these guys are equal. That's the important thing. Is it necessary to draw the principal axis? Absolutely yes, right? For most of the diagrams, you will see it. So you must draw the principal axis. And we'll see that in the next class, okay? Now we are doing the basics. So make sure you guys practice it the right way, the smart way, okay? So measure these distances, then draw the arc. How do you draw a convex mirror diagram? Same thing, only it is, the opposite side. So because this is the reflecting side, so we tend to, the circle will be drawn this way. Now, once again, this is your principal axis. So your horizontal line, and make sure you're measuring again equal distances. So if let's say this is your pole, your focus, if this is your focus, and this is your center of curvature. So this is my pole, focus, and center of curvature. Again, you can keep, 2 centimeters, 3 centimeters, whatever you want. They basically need to be equal. Your object will be placed here. When you're doing this reflection, so the object is going to be placed here, the rays will go here and reflect off this mirror. And then again, you place your compass point over here and draw this arc, okay? And this time it's a convex mirror. So make sure this back portion has the dashed, okay? So this is the non-reflecting side, right? Just like we draw in a plane mirror. And this side is the reflecting side, the smooth side without any of these dashes or marking. So there you can see this is the convex mirror diagram. Again, focus is exactly between P and C. If this is 2 and this is 2.1, your diagram is going to go wrong. Okay, so measure it very carefully and accurately, and use the compass to draw a nice big arc. So there are a lot of light ray rules, right? And again, remember, make sure you draw your diagrams like this. So you have the center of curvature, your focus, pole, which is exactly the center of the mirror. In convex mirror, it is this side. So here it is in front of the mirror, because the curvature is this way. So obviously your center of curvature will be this way. Here the center of your compass should lie this, because the curvature is this way. So this is your center of curvature and your focus. So there you can see. And so now we are going to talk about light ray rules. So for example, if you have some random ray, like let's say you have this ray, after reflection, where will it go? Or if you have a ray like this, where does this ray go? Or if you have a ray like this going towards the focus, where will this reflect off and go? So there are some standard rules which make it very easy, so that we can use these light ray rules to predict where the image will be located. So let's talk about rule number 1. So what does rule number 1 say? And we'll do it together for a concave and a convex mirror. And there you can see these are your P, F, and C, center of curvature, focus, and pole. So if you have your light ray which is parallel to this principal axis. This is rule number 1, where you can see the ray of light, again the thin line of light, which is parallel to the principal axis. Where does this ray go? Okay, so what will happen here? This ray, after reflection, the rule is if it is parallel to the principal axis, the ray after reflection passes through the focus. So let's draw that here. After reflection, this ray is going to pass through the focus. There you go. Same thing in a convex mirror. It may look complicated, but same thing. But should you do this? The ray of light parallel to the mirror, it passes through the focus. Is this correct? Is this the right answer? Yes or no? What do you guys think? Have I drawn the correct diagram? See, I did the same thing as concave. I took the ray of light passing to the focus. So I'm happy to know that most of you think this is wrong, because what is the problem here? Mirror looks to be like transparent. The ray of light is going through the mirror. The ray of light is just going through. No, mirror is opaque. So definitely this is wrong. What is going to happen? This ray of light is going to get reflected, bounced back from the mirror, but it will appear to come from the focus. So it appears to come from here and it is reflected off like this. Can you guys see that? So again, parallel ray as if it is coming out from the focus. Here it is actually going through the focus. And make sure this is dotted, because this is like a virtual ray, right? Or it is not real. The real ray of light is here, because it cannot be behind the mirror. So this is your rule number 1. And make sure, please, again, I'll keep repeating, make sure you guys draw those arrows. Arrows are very important. Next, guys, rule number 2. If the ray of light is passing through the center of curvature. So if you take the concave mirror case, this is my center of curvature. This is the focus and pole. If it passes through the center of curvature, what is the rule in a concave, in a spherical mirror? This thing. So you guys know that when it is passing to the center, this ray of light is like a radius. Do you guys agree? Because this is a big circle. So is it not the radius, the line joining the center to the end of the circle? And we know that this radius is going to be perpendicular to, if I draw this tangent here, do you guys agree? If I draw a tangent over here, using the circle property, we know, or if you guys don't know, you're going to learn that the radius is perpendicular to the tangent drawn at that point. So tangent means what? If I look at this portion of the mirror, this is like a small plane mirror, this tangent mirror, small plane mirror. So if the ray of light is directly falling on this part of the mirror, after reflection, what will happen? Since it is perpendicular, it will simply go back, right? It is falling on the mirror. After reflection, it will simply go back. Because it is normal incidence, it is falling perpendicular. So it will simply go back along its path. So this is one rule which confuses some people. Why is it going straight back? Because this radius of the circle and the tangent, by that theorem, radius and tangent are perpendicular. Tangent means this small part, this actually curved mirror is made up of small tiny mirrors. So if you consider this small part here, this part, this is like a plane mirror. So it is behaving like a plane mirror and just reflecting off the ray back. So that's what's happening here. Similarly, what will happen here? If you take in a convex mirror, you have your pole, focus, center of curvature. All you have to remember, if the ray of light is going through, or it was going towards, not through, it cannot go through it. It is going towards the center of curvature. Same thing will happen. It will simply reflect back. It will trace back along its path. So just like it traces back here, this is going to happen. So these rules make drawing ray diagrams very, very convenient, because these are like the standard rays here. So here we say it retraces the same path. Now let's look at rule number 3. If the ray of light is passing through the focus of the mirror. So there you can see, we'll start off with concave. This is our center of curvature, the pole here, center of the mirror, and focus exactly in the middle. If the ray of light passes through the focus, what will happen to it? This is actually the reverse of rule 1. In rule 1, what happened? Ray of light parallel to the principal axis passes through the focus. Now we are doing the reverse. if ray of light passes through the focus, what will happen to it? It will become parallel to the principal axis. So that's what's going to happen here. The ray of light passing through the focus after hitting the mirror is going to become parallel to the principal axis, right? So after hitting the mirror, this ray is going to become parallel to the principal axis. So basically rule 1 and rule 3 are reverse of each other. Why? Because of reversibility of light. Light will just reverse its path. So if you draw a parallel ray, does it look parallel? I hope. So if you draw a parallel ray, it will pass through the focus. If you make the ray pass through the focus, it will reflect off and become parallel to the principal axis. Clear? Same thing here. The ray which was targeted towards the focus, which is exactly in the center of curvature and pole, after reflection. Same thing, what's going to happen here? It was meant to go towards the focus. After reflection, it becomes parallel to the principal axis. So just remember, rule 1 is the reverse of rule 3 here. There is one more rule. Rule 4, if the ray of light is falling exactly at the pole, so the point of incidence is the pole. So what is going to happen here? So if you guys see again, remember this center of curvature, the focus here. So line joining pole and center is like our radius. So that is going to be perpendicular to this tangential mirror here. Do you guys agree? So this radius is going to be perpendicular to this tangent kind of mirror here. So this radius is acting like the normal. So therefore, if we use a compass and let's say we measure this angle, and if this angle is 20 degree, this is behaving like a small tiny plane mirror where this is our normal, PC is the normal, this is our incident ray. So what is going to happen? This ray will reflect off exactly like this, having the same angle of reflection as the angle of incidence. So it's going to be 20 degree again. Can you guys see? Angle of incidence will going to be equal to angle of reflection here. Yes, it will reflect off at the same angle. So the important thing, we are using at the pole, angle I equal to angle R. Same thing for a convex mirror here. It is incident at the pole. This was your focus and center of curvature, of course. And so because this is acting as the radius, the normal here, so again the ray of light will reflect off, making the same angle. So let's say suppose the angle here was 30 degree. This is also going to be 30 degrees here. So this is like our pole rule, where angle of incidence is going to be equal to angle of reflection. But one important thing here, please avoid using this rule in the ray diagrams. Why? Because measuring these angles accurately, like suppose it was 15 degree or 17, then measuring it accurately, even 20, with the compass, the measurements are not that accurate. So the ray diagrams may not be so accurate. But the previous rules never relied on any of the angles. It was just parallel line passing through the pole, through the focus. Here you had passing through center of curvature, gets reflected back, and in the last one, passing through the focus becomes parallel. So these did not use angles. So I would just say avoid using this rule, even though it's valid, avoid it, because angles are very hard to measure. Unless they give you a direct question, okay, they ask you some question based on this diagram, then you should do it. But for ray diagrams, this rule is to be avoided for ray diagrams. And we are going to practice the ray diagrams in the next class. So make sure you revise this, watch the previous videos before attending the next class. Now, one very interesting thing is random ray. If we have this kind of random ray, so you can see it is not following any of the rules. Is this ray parallel to the principal axis? So here you have your pole, focus, and center of curvature. These are pole, focus, and center of curvature. So is this ray parallel? No. So we cannot use rule 1. Is it passing through center of curvature? No, we cannot use rule 2. Is it passing through the focus? No, we can't use rule 3. Is it incident at the pole? No, we can't use rule 4. So I like to call this the random ray. Okay. So what do we do in this case? We know that when it is hitting the mirror, where do you guys expect this? This ray is not going to go here. because it is not transparent, so that is wrong. So if this is kind of a curved mirror, I'm expecting it's going to come something like this, right? It's going to reflect off like this. Do you guys agree? Okay. But how do we draw it accurately? Roughly this looks correct. Okay, it's hitting here, it should go somewhere here. But is it going to focus? Where will it go? So how do we do some more accurate estimate of where this ray is going to go? So again, there, what we are going to do is we are going to use the idea that if at this point of incidence, this is my point of incidence, O. So if I join, all you have to do is join O and C. Just join the point of incidence and the center of curvature, because this is like the radius of the circle. So it is definitely going to become again the normal to this small plane mirror here. This is like a small tiny plane mirror, because circle is made up of small tiny lines. So you can see that this is basically going to become the normal to this incident ray. So after reflection, you guys can guess it is going to go like this, where what you can do is to measure it accurately. Suppose this angle was 25 degrees, then this angle will also be 25 degrees. Do you guys agree? It looks a little larger than that. So maybe let's say I say this is, or let's just say this is 30-degree angle or 40 degrees. Okay. So what you can do is you just join O and C, you measure this angle 40 degree, this angle here equal, and you will get your reflected ray perfectly, because OC, the important point is OC is the normal. The line joining the point of incidence to the center of curvature forms the normal. You measure this angle of the incident ray with the normal, you draw that equal angle, and boom, you're done. So yes, it passes somewhere between P and F. Same way, what will be the random ray rule over here? Follow the same procedure. Look at the point of incidence. So this is clearly my point of incidence over here, which I can label as O. And this is my pole here, the focus and center of curvature. Again, what is the rule? Join OC first, okay? Make your normal. So we are going to join O and C and extend the line like this. Now, once again, measure this angle. So suppose this angle turns out to be 30 degrees. You draw the same angle here, because you know after reflection it's going to angle I will equal to angle R. So this is going to be same angle here. So do spherical mirrors obey the laws of reflection? Does angle of incidence equal to angle of reflection? The answer is yes, as you can see here, because a spherical mirror is made up of tiny small parts or tiny plane mirrors. So definitely it is following the laws of reflection. You just have to draw that normal OC, you join that, and there you can see angle of incidence equal to angle of reflection, and there you're done. And another important thing you guys need to know, which will be useful in the next class, what are the types of images? So images can be divided into two types: real image, virtual image. We'll see this more in the next class. The important thing is real image can be taken on a screen. So just like when you go to the theater to watch a movie, they are projecting on a screen, so it can be captured on a screen. It is a real image. Real images are always inverted upside down. Why don't you see the inverted image in the movie? Because they invert the projected thing, right? And light rays actually meet at the point. So real means the light rays are actually meeting to produce the image. Whereas virtual image, it cannot be taken on a screen. So real image on a screen, virtual cannot be taken. Real image is always upright, or we say erect. These guys are upside down, inverted. Inverted means upside down. And light rays appear to meet. So in virtual image, the light rays don't actually meet. They seem to be coming from a point. So we'll see that. So this is an important thing you should remember for the next class. So there we have come to the end of the topic of this introduction to the reflection by spherical mirrors. Hope you guys enjoyed this class. Please take a look at the previous videos and revise this topic, because in the next class, we are going to be practicing ray diagrams. You can also watch, there's a video on that, but I'm going to show you practically how to use the rules, and remember to practice how to draw convex and concave mirror diagrams. And do check out the other courses on our website. We have physics, chemistry, biology, and maths for CBSE class 8, 9, and 10. So guys, if you haven't taken the other subjects, what are you waiting for? Do take them and do share it with your friends. We also have ICSE courses, physics, chemistry, biology, and maths for classes 8, 9, and 10. Once again, do check out the other courses on our website and please do share it with your friends. And if you want to learn coding, we have Python programming, we have Java coding. So all these awesome courses there for you. And we have physics and chemistry for the Cambridge IGCSE, which is the international board. So make sure you share our website and our Android app with your friends. And also you have subscribed to our YouTube channel. You can follow us on Facebook and Instagram. We keep posting interesting content there as well. So hope you enjoyed this physics class and keep learning.